This is Lecture 3, Chapter 4. In this class, I shall tell you about number 1, functional groups, number 2, homologous series, and number 3, nomenclature of carbon compounds. First, I tell you what functional groups are. Carbon forms bonds with other elements besides hydrogen. These elements may be halogens, sulfur, oxygen, and nitrogen. One or more hydrogen atoms are replaced by these element atoms depending on the valency of these elements. Such an atom different than hydrogen is called heteroatom. A heteroatom forms group with carbon and hydrogen that causes certain specific properties to the carbon compound to which it is added, irrespective of the chain size of the compound. Have a look at some of such groups. Oxygen forms a number of such groups. These are number 1, alcohol and formula is OH. Number 2, aldehyde and formula is CHO. Next is ketone, formula is CO. And next, carboxylic acid, formula is COOH. Remember that these are written in the same order and not in any other order. For example, aldehyde is always written as CHO and not COH or HCO. Similarly, ketone is written as CO and carboxylic acid is written as COOH. Next, I tell you about homologous series. Have a look at these carbon compounds, that is CH4, C2H6, C3H8, CS3OH, C2H5OH, C3H7OH. All such compounds have a common functional group and their chemical formula varies just by CH2. Such a series is called homologous series. We can have homologous series for alcohols and similarly for carboxylic acids. Next subtopic is nomenclature. Carbon forms a very vast number of compounds. Naming of carbon compounds is done according to the following rules. Number 1, identify the number of carbon atoms in the carbon compound. Number 2, identify the functional group. Number 3, if no functional group, then look for the double or single bonds. If all bonds are single, the hydrocarbon is named with suffix ane. For example, if carbon is 1 and all 4 are hydrogen atoms, then it is methane. If number of carbon atoms is 2, all other are hydrogen atoms and these are singly bonded, then it is ethane. And if 3, propane, and 4, butane, and so on. If any carbon-carbon bond is double, then replace suffix ane with ene. For example, in ethane, if 2 hydrogen atoms are removed and carbon-carbon bond is formed, then it is ethene. Same is with propane. Propane becomes propene and butane becomes butene. And if any carbon-carbon bond is triple, then ane is replaced by a suffix yne. For example, ethane becomes ethane, propane becomes propine, and so on. Rule number 4, if a heteroatom is present, then identify the functional group and follow the following rules. In case of halogens, prefix the halogen name by replacing INE in it with O and then write the parent hydrocarbon name. For example, CS3Cl is chloromethane. And similarly, if it is bromine, then bromomethane. And if one hydrogen atom is replaced in ethane by fluorine, then that becomes fluoroethane. If hetero atom is O, then identify the functional group. If it's OH, that means it is alcohol, and suffix OL is used instead of E, or suffix E is replaced by suffix OL. For example, here this is butane, and when one hydrogen atom is replaced by this OH group, then instead of E we would write OL, so that the name becomes butanol. In case of ketone or CO group, E is replaced with ONE. Therefore, butane becomes butanon. In naming an aldehyde, suffix E of the alkane is replaced by Al. So here this is butane. Butane becomes butanol. To name a carboxylic acid, suffix E is replaced by oic acid. Butane becomes butanoic acid. This is brief about the nomenclature of hydrocarbons. You shall study about hydrocarbon naming in detail in higher classes. In the end, let us summarize what we have learned today. First, we learned about the functional groups. One or more hydrogen atoms in a hydrocarbon can be replaced by some other element. For example, halogen or oxygen. Such an atom different than the hydrogen is called a heteroatom. A heteroatom forms group with carbon and hydrogen and causes certain specific properties to the carbon compound, irrespective of the chain size or the chain length of the compound. For example, OH, CHO, CO and COOH are some of such functional groups. Next, we discussed about the homologous series, the hydrocarbons whose chemical formula differ just by NCH2, where N is a whole number. Such compounds belong to the same homologous series. The compounds of a homologous series have similar chemical properties. For example, alkanes have similar properties, while alcohols, different alcohols, they have similar properties. Similarly, aldehyde or ketones and so on. After that, we learned how to name the hydrocarbons or the carbon compounds, means the nomenclature of the carbon compounds. The first step is what? We have to identify the number of carbon atoms in a compound. That is the first step. Second step, we have to look for, is there any functional group? If no functional group, then we need to look for a double or a single bond. If all bonds are single, the hydrocarbon is named with suffix A and E. If, for example, if carbon atom is 1, then it is methane. If 2, ethane. If 3, propane, and so on. If any carbon-carbon bond is double, then A and E is replaced by E and E. For example, ethane becomes ethene, propane becomes propene, and so on. And if carbon-carbon bond, even if a single one, is triple, then suffix Y and E is added instead of A and E. For example, ethane, propane, and so on. And if a he2 atom is present, then we have to find out the functional group. In case of a he2 atom is a halogen, then prefix the halogen name by replacing I and E with O, and then write the parent hydrocarbon name. For example, methane or bromomethane, and so on. And if functional group is OH or alcohol, suffix OL is added instead of E, means methane becomes methanol. And in case of ketone or CO group, ONE is the suffix used, means butane becomes butanol, or and so on. And in aldehyde, AL instead of E, means methane becomes ethanol, and so on. And if it's carboxylic acid, then the name is suffixed by oic acid. For example, methane, here E is replaced by methanoic acid. That's it, this lecture. We shall continue this chapter in next lecture. Till then, goodbye.